Is Anders, do you want to share your screen? Are you here?
I'm here. I think in the interest of time, I'm just going to talk without slides.
Please.
Also because what I have to say is super simple. Also just sort of connecting some dots. I think what I'll be talking about and what I'm talking about in the YouTube video is aligns really well with a lot of what you're going to hear later from Valerio as well as Zhou. So very briefly put, my sort of talk is really just a reminder that language is a moving target and not something that we can really sample from at random. I think sort of compared to 5-10 years ago when I first started talking about these things, this has sort of become a consensus view. And for that reason, I wanted to make my talk more about sort of what you can practically do to sort of compensate for that. So the talk is a really simple talk. It's really just a list of 5 things you can do to sort of make your benchmark data, your evaluation data sets more interesting, more relevant, and sort of enable more studies of the kind of studies that people are interested in doing these days. So what I can do here is just sort of list those, and then we can discuss any of them as you see fit. So one thing that I talk about is the importance of adding timestamps. So there's a lot of NLP data sets out there with a lot of sentences, a lot of paragraphs, a lot of documents without timestamps. And given that one of the things that we're becoming more and more concerned with is the fact that language changes over time. It's a moving target, and our performance numbers may drop as a consequence of that. Just having information about when texts were written or when document or examples were constructed is really, really useful. For some data sets, the information is out there. Like if you dig a bit, you can find it for the Penn Tree Bank, for example. But it's just such a simple thing to add that I felt like this was an important thing to put on that list. Another thing, and this relates to what Valerio is going to talk about later, I think, well, actually a couple of things that I want to talk about relate to what you'll talk about, is just the demographics. So one thing is who wrote the text, and you know, this is obviously also related to Nan's worries about the bias in the systems that we train based on the data. I think relating to Brian's talk, it's also not entirely clear what demographics are most interesting to look at. So to the extent that we're doing this, so adding writer demographics to our data sets, evaluation data sets, we tend to focus on gender, age, race, things like that, which of course makes a lot of sense given that these are protected attributes, but they're not necessarily the attributes that vary with performance the most, and things like dyslexia or aphasia would be really, really interesting to have in our data sets to the extent possible. So this is important for writer demographics or speaker demographics, but it's also important for annotator demographics. So for a lot of our tasks, there's a lot of systematic disagreement. This is what Valerio will talk about. And some of that varies along demographics. So people have different views on grammar, syntax, semantics, what's hate speech, what's not, what's positive, what's not, etc. And some of those disagreements are systematic and vary across demographics. It's really important to have annotator demographics if we want to make sure that our systems are not biased toward a certain demographic. So these were kind of the first 3 things that I mentioned in the talk. Fourth thing is the importance of having multiple annotations. This is also, again, what Valerio is advocating for. So basically the point here is just like, you know, once you've added those 3 things and you have some spare time, one thing you can do is annotate the data over again. And the reason for that is, of course, because that that information is important. So it's more important that our systems are right on the things that everybody agrees on than on the things that where opinions are all over the map. So that information is often missing. Sometimes it was there at some point before adjudication, and people just sort of didn't publish that information. And I feel like that's a bit of a pity. So this also, for me, is sort of a simple thing you can do to make data sets more interesting. And finally, and this is sort of more of a general point, if you have even more time left, do another benchmark. And this is sort of more of a philosophical point, that because we are so bad, for good reasons, at sampling from language, it doesn't really make sense to have a single test data set for a task. And I think it's interesting to sort of think about the analogy with actual benchmarking, so surveying or drawing height maps, right? A single reference point is just not very useful for understanding the curvature of a landscape, which is also the business that we're in. And I think it's really important to have multiple independent samples of the thing that you're interested in order to understand the curvature of that landscape. In machine learning, when you publish a new classification algorithm, the sort of rule of thumb is to have more than a dozen data sets in your evaluation. And I think probably we should have something like that for each of the tasks that we're interested in, even within a single domain, ideally. So Dao later is going to talk about Dynabench, which is kind of a really, really interesting approach to this. And I think of this as sort of a search strategy within that landscape. We also briefly talk about adversarial approaches to finding data. And this is, of course, potentially sometimes a very efficient approach to sampling from this landscape. I think it's an empirical question, sort of what the pros and cons of that approach would be. But yeah, that's what my talk is about.
Well, that's great.
Okay.
Yeah, please, Valia, please take it away.
Well, yeah. Can you hear me first of all?
Yes, I hear you wonderfully.
Okay. So Valerio would have a question first, and then I would follow up on this.
Yeah. Okay. Hi. I have comment on the fourth point you made about the importance of having multiple annotations or many annotators. You said something. I agree with all the other things you said, but you also said that we want to make sure that models are correct more where people agree, and that it's less important that the model is correct when there is opinions all over the place. I'm not sure I agree that that is the case always. I think it highly depends on what is the phenomenon you're modeling. If you're modeling a phenomenon where there's a lot of opinions. I'm also making a kind of a teaser for my own talk in a few minutes. When it's a phenomenon where there are a lot of opinions involved, like I work on hate speech and abusive, offensive language. I think we want systems that also. I think we value that where there is that disagreement. I think that's also the main point of my own talk. So I'll just stop there on this specific comment. I don't know what's your opinion on that.
Yeah, thanks. That's a really good question, and I think you're right. This depends, I guess, a little bit on the application, but I am also not entirely sure that what I just said is something that I mean. But what I do think I mean is that we, in a lot of cases, we want to build systems that are not too bad for any demographic. So in some sense, I think what we should care about is sort of the worst case performance across a lot of different things. All the domains that we're interested in, all the languages that we're interested in, all the kind of timestamps that we're going to be employing our system in the future, but certainly also across all the demographics. And so this is not the same as saying that we should only agree on things that people agree on. So as you talk about in your talk, there's certain different types of agreements, and I think for some of the types of disagreement, we are interested, and for some tasks, we might be more interested in at least learning from the things that people agree on to sort of provide it. But maybe this is not entirely the same as saying that we should be interested in worst case performance across demographics. But yeah, it's a good point.
Thank you.
That was more or less my question also, so thank you for this, Valerio. I am currently on my mobile phone, so I have very little capability to see or whether other people have raised hands. I'm sorry about this, but
I don't see a question, but if there are any,
thank you.
please speak up. Good. Yeah, so I think one of the things that John Massey is likely to say when we hear from him is when you have a portfolio of variables or a portfolio of tests, then you have some advantages. You can see things that, you know, that's great, but also that you probably don't want to just take an arithmetic mean. I think he's going to argue for some other summary statistics. And that, you know, sometimes the outliers are really important and you want to weight them a lot, and sometimes they're not. You want to disweight them. Mark, I see you have a hand up.
Yeah, I wanted to mention that there's a surprising similarity of these very important issues to issues that arise in laboratory animal testing of pharmaceuticals. Just for example, annotator demographics, the people who are performing the experiment, who are injecting the animals or feeding the animals or cleaning their cages, it matters who they are. It matters what kind of cologne they wear. It matters when they come in. So that the timestamps, you know, do you do it first thing in the morning or do you do it in the evening? Are there windows in the animal rooms so that the light is coming and going and the animals sync their biorhythms and so on? And I won't go into, I mean, you can look all that up in the literature. People have been concerned about lack of reproducibility in experiments of that kind for a long time. And it's because everything matters, even the things that you think are irrelevant. And so you take the same experiment done with exactly the same strain of mice with exactly the same dosages of chemicals in two different labs and you get different results. Well, why? Because there are all these other uncontrolled covariates.
Mm-hmm. Yeah, so I guess the least is that we should just log as much as we can. And one of the easy things to do, and I think with the emotion data set, I've seen this, they actually log judge IDs by every judgment. They don't, it's anonymized, but even then. So you can see that, in fact, there are some judges that are doing much worse than the systems.
I'll mention also that in some of the work that we've done on clinical analysis, where there is an interviewer and an interviewee, yeah. We actually can do just as well on diagnosis by analyzing the interviewer's speech as by analyzing the interviewee's speech.
Yeah, that's disturbing, isn't it?
Yeah. Well, no, I would think it's encouraging.
Oh.
all in your point of view.
Okay.
Sam is making a point on the chat,
okay.
pointing to his knuckle presentation and knuckle paper. So, Anders, if you can see that.
I am just reading it, and sorry, Sam, if I was in any way misrepresenting your very cool paper in the YouTube video. I think sounds like we're totally in agreement. I think modeling the distribution of what people have to say, of course, sort of that's multidimensional in so many ways. But then I agree, of course, with the test set labels being reproducible. But as Mark also just pointed out, there's so many covariates here in this space that it's hard to do in practice. And I guess what I was getting at, and I think this is the part where I'm probably misrepresenting what you're saying and just sort of trying to represent something that used to be a consensus, is sort of that the notion of having a gold standard represented in some discrete form is sometimes a bit of an illusion.
Yeah, that makes sense, and I agree. And just chiming in to say I have no argument against any of that. That the short version of the paper might hint in the opposite direction, but I agree.
Cool, but thanks.
Hi, this is Helen. I can't raise my hand apparently in the
Ah, okay,
browser
please
chat,
speak
but,
up, Ellen.
So I did lots of study on assessor for information retrieval, assessor disagreements, right? So it's well known in the literature, not just from me, but well before me and after me, that if you give two people the same document and ask it if it's relevant to a question, they will have different opinions. I mean, not all documents, but enough that you have to pay attention. And in fact, I mean, so largely, I guess I'm saying I disagree with what was just said here. If you have a human, if the task that you are trying to benchmark is relating to an actual user task, at least some abstraction of it, but it does relate to a human task, then this distribution of labels doesn't really matter, because the only thing that's going to matter for the end user is his or her own opinion, right? And so the technology is going to have to deal with the fact that there is no truth. And that's one of my parts that I have said over and over again in papers, and it's in my talk here. There isn't truth, at least not for retrieval, and frankly not for question answering. I did the same study that I did for document retrieval for factoid question answer. So these are factoids. Who invented the paperclip, right? Assessors disagreed on that because of the granularity issues. You know, was the last name sufficient? Was it last name not sufficient? If you ask dates, there's the granularity. How specific do you have to be at the date? If you ask places, how specific do you have to be, right? Is a continent enough? Is a planet enough? Does it have to be address, right? I mean, so humans disagree on everything. And you're going to have to really take that into account when you are devising what it is that you're going to claim that your benchmark represents. Okay? And so different from most NLP evaluations, information retrieval has a very long history of saying, yes, assessors disagree. We will create relevance judgments, which we will treat as gold standards, but we know that they're not. And because of that, you can't compare across collections, right? The noise that different humans introduce, and other noise, but the noise that different humans introduces means you can't compare on across collections. You can't compare. So a subset of a collection is a different collection. And you really need to be careful about what you claim that you can say from a benchmark. And I will be I'll have more of a diatribe later on today, so I'll stop here.
No. Well, that's I mean, diatribes are much appreciated. And I was going to show something which, you know, underscores exactly what you say, but maybe I'll bring it up when you give your presentation later. I'm worried that we're badly behind time, so maybe we should go on to the next talk, if that's okay. Valerio, are you here?
Yeah, and so in the interest of time, I made a very short version of the presentation, so I'll try to keep things very short. Also, we were just talking about many of the things I will say, so try to be short. Let me try to share my screen. Okay. Now, okay. So we sent a short paper averaging half a page per author here, because this work comes from a collaboration. We tried to, myself and the other 7 people listed here in the slide, we tried to put together our thoughts and our experiences with a specific aspect and of the whole benchmark procedures in general. That is the creation of data sets, mostly in NLP. We're all NLP people, and the disagreements that comes with the annotation. That's the focus of our work here. Yeah, we call it a position paper because there's nothing new in terms of experiments, but again, our purpose was to put a series of observations one after another and see if there is a common goal, and perhaps some some solutions. I like to think that we have a strong position but mild solutions. So you'll see what I mean in a second. But to get straight to the point, and again, we just talked about some of these aspects already. What we do typically in NLP, but not only in NLP, also computer vision, for instance, is to create data sets for benchmarking, for training and for benchmarking as well, is to we annotate with many different ways. We annotate data sets. We create a ground truth. We create a gold standard. Usually, then we aggregate somehow the many annotators, even if we have many annotators and maybe a low inter-agreement scores, still there is some kind of aggregation at some point, because all of these procedures relies on this assumption that there is one truth. And I just heard something I was very happy to hear, that in many cases, especially in NLP, there is no truth. At least I can say there is no single truth. And I'll explain what I mean. But in a nutshell, our work led to the conclusion that if we were in benchmarking NLP under the assumption that there is one single truth, then we are just getting rid of a lot of the important nuances that are in natural languages, the subjectivity of tasks, the complexity of many tasks, and there is a problem. And we also discussed among us that there is a problem for evaluation itself, and that's why we targeted this particular workshop for this work. One of the things we did was to try and understand where these disagreements come from. So one of the expressions I heard over the past talks today was the systematic disagreement. So we try to categorize a few of the sources of disagreement that we saw in the literature and in our own work. One is that sometimes the disagreement comes from the stimulus itself, so from the language itself, for instance. In natural language sometimes is inherently ambiguous. So there is some ambiguity that you just cannot get rid of. And there were examples in the literature about humor. So humor sometimes is based on ambiguity. So the ambiguity is part of the message. It's not just something you can treat as noise. Or disagreement can come from the context in the most general sense of the word context, even just the state of mind of the annotators. Anders was talking about have your data sets annotated by many people, many different people, but even sometimes the same person annotating the same data set, maybe after 6 months, will have less than perfect inter-annotator agreement with themselves. This has been observed because there are so many other factors involved in the human judgment. And finally, another, and we already discussed that, source of disagreement is it comes from the fact that annotators are people, and people are different from each other. They have their own opinions, judgments, their own background, their own culture, their own understanding of a language, and all these other factors. And the main point is that on one hand, we want ideally a diversity of annotators. So this has been said in one of these talks talking about robustness in psychology, in psychological experiments, but also in when creating a data set for NLP, we'd like to have a diverse set of annotators, which is very difficult sometimes. But what I argue is also that we want to know who they are, because who the annotators are in terms of their, generally speaking, their background, can have a specific effect on their annotation, depending on what is the phenomenon, maybe depending on what the topic of the language to annotate is, and so on. So again, I said we have a strong position but mild solution. So the position we hold, and we are not the only ones, of course, that we didn't invent any of this, is that we need to abandon this assumption behind gold standard idea. So for some tasks, at least, there is no possibility of having one gold standard, one single truth that encodes everything that's correct, and use that as a benchmark. And that's a problem, because that undermines all the rest of the pipeline that we, for evaluation that we typically use. So we can create a system that learns from disagreement, for instance. One of the things that I talked about in the full talk in full video is a seminal task organized last year called Learning from Disagreement, when, where models were invited to be trained on disaggregated labels, so all the labels or distributions of labels. That's something we can do, granted that we don't aggregate the annotations when we create data set, but then we still have to test it against a single truth, and that's still a problem. So if we destroy this assumption of having a single truth, we really have to reinvent the whole, or at least to adjust the whole evaluation also at the end. We need to compare, for instance, one of the solution that has been proposed by some of the other authors of this paper is to use soft labels, which is basically distribution over labels. We were just discussing about that. Also, Sam had a comment, I think, slightly on that. And then you can evaluate predictions that are themselves distributions over labels against distributions which are, let's say, gold distributions. And this can't be, this seems to work in terms of giving a more robust evaluation. It's more similar to a realistic evaluation, whatever that means. But also other things have been tried. Myself, I tried a more extreme version where I'm just not aggregating anything. And just if I have 6 annotators, I'm just training 6 different models. Now that works less well in terms of getting a final number or a score. But there are important implications in what you can understand or what you can explain from the evaluation. And somehow you can reconstruct part of the identity of who the annotators are while doing the annotation. And this is useful, for instance, when you have an annotation created with crowdsourcing. So finally, just to wrap up, our position is that we need to get rid of the single truth. We need to get rid of gold standard. One of the papers cited is called "It's the End of the Gold Standard." There's other works in recent literature are starting to talk about diamond standard, which means publishing data sets with all the full annotations. And then researchers will do whatever they want with it. But the important thing is that we stop harmonizing data, we stop aggregating annotations before publishing them. Let's just distribute everything. And so to embrace the complexity, the subjectivity, and all the other factors that go into the judgments of the annotators, let's just distribute everything in a very scientific way, and then let's give everything to the community, and they will come up with the best ways of creating their learner models and evaluating them and so on. And finally, maybe I'll just put the link in the chat. Some of this, including this call to arms to publish disaggregated data, we collected it in what we call Perspectivist Data Manifesto. And as a promise, I try to keep short. So if you have questions, I'm happy to hear them.
So Valia, are you?
Thank you very much. Yeah, I'm with you on and off, but I have thankfully to the contributors I have heard the talk. So thank you very much, Valerio. Can you go on with because you have posted.
I just posted
2 comments.
something. Well, the 2 comments are pretty much the same thing, and they're really in violent agreement with just what this talk said, but also I think what Ellen said. And so I pointed out a data set that's the visual genome, where they assume there's one and only one label for each bounding box. And I say that's really not workable. And in Trek and in web search and information retrieval and machine translation, it's assumed that we would have more than a single reference. You really couldn't imagine saying the only right answer is whatever the first translator comes up with. So, I think this is a point that's well taken. Maybe the bigger challenge is not how to preach to the choir. We're probably all convinced, but why is it that there's so many databases that get benchmarks that get this wrong? So I think somehow we need to explain to the people who are getting it wrong why it's so wrong and what damage it does. But I think the point's right on.
I think in part by chance, I stumbled over a very good way of explaining why this problem is a strong problem. And also, I'm showing part of the full presentation with a very similar example to the one you posted in the chat, because I had problems downloading it. So you see this inherent ambiguity in labeling tasks for images, for instance, right? So in the picture there, the question was, what's the background metal structure? And yeah, it is correct that it's a platform, but it's not wrong that it's a roof or a shelter. So,
yeah.
This is one thing, but to answer the second part of the question, I dedicated the past 4 or 5 years to the NLP area of abusive language, offensive language, hate speech. And I found that there it's very easy when you deal with those tasks, which I call highly subjective tasks. It's much easier to explain the effect of aggregation on the negative effect of aggregating the annotations to the creation of data sets and ultimately to the evaluation of models. We did so that one of our PhD students, for instance, created a hate speech data set, so just binary classification task on tweets, but he put good care into selecting the annotators to very separate groups of annotators, and they give very, very different answers, and the answers are very polarized, meaning that one group, which are, I think they are Muslim immigrants in a specific country, they highly agree with each other, and the control group, which are the people, the Western background, white college students, they also agree with each other a lot. But the two groups together, they create two different gold standards that are very different from each other. We actually came up with a measure of this polarization index. So one of the good ways I found to explain why this is an important issue is starting from examples from highly subjective tasks.
Yeah.
Even though, I say that in the talk, even though we found, especially the other people that worked on this, inherent ambiguity and disagreement everywhere in all the layers of linguistic analysis, even part of speech tagging, there's some ambiguity even there that cannot be resolved.
All right. Somebody, Agostina, you have your hand up?
Yes. Thank you, Valerio, for your talk. I had a couple of questions. So I was thinking about hate speech. So when considering like a social science application, I don't know, I want to study the behavior of haters. Like I totally get how to include multiple label settings, but I was wondering, like in a content moderation setting where you had to make a final decision in the end, how do you think this multiple label setting would work? Like, should we focus on keeping multiple opinions, or maybe collecting as many factors as possible in order to make the problem as objective as possible, like squaring the circle, I would say. So this is the first question. Well, okay, I'll ask one.
Oh, sorry, go on.
No, go ahead. I can ask you.
Okay. So this is interesting because when you want to do automatic content moderation, it depends on who you are. If you are a company, maybe you are interested in, be on the safe side. And this is actually very similar to the first experiment we did on hate speech in this line of work, where we created, so basically we divided the annotators, we clustered them, and then we created two different classifiers that they were sensitive to slightly different aspects in order to classify them as hate speech. And then we just created what we call the inclusive classifier, but inclusive here is just in the logical sense, like the or, inclusive or classifier, meaning it's a very simple ensemble. So if the first classifier or the second classifier or both just label an instance as hate speech, then it is hate speech. This is a choice, a design choice, But at least in the case of hate speech, that means being on the safe side. And this actually fared better than the baseline, even on a standard gold standard benchmark. So it is still better to be on the safe side, even if you may get some false positive, of course. But yeah, but it depends on who you are and what your application is, I guess.
Thank you.
You had another question.
Yeah, I had another
I hope I replied to this one.
Yes, thank you.
I'm worried. I'm sorry. I'm just worried about time. We have another
right.
talk in 5 minutes. Mark is probably hosting the next session. He'll maybe allow us to go a little bit.
I'm happy to take after questions online.
Yeah, I'm sorry.
Or as long as you want, I've got no problem.
All right. Do you want to go quickly, or should we move on?
I can ask a question.
All right.
So I think my main question was, how do we recognize constructive disagreement from one that could be an harmful disagreement? So it's still by taking control of the demographics of the annotators. Like I can think of someone seeing the good intention behind catcalling or claiming that LGBT labels are not useful just because they don't understand like the view. So I think my question here is, where do you draw the line between considering multiple opinions between and then leaving some harmful content for freedom of expressing opinions?
I think that's a very interesting and advanced question, and I'm far from there. The thing that we're trying to do now is to try to understand who the annotators are just based on what they annotated. And that may be seen as a first step in that direction. And then when you try to, when you understand, when you model more and more about who your annotators are, then you can start to understand why they gave certain judgments, and maybe that will go someday in the direction of what you say, but we're probably very far from that. Yeah. But I'm noting it down. Thank you.
Thank you very much.
All right. Why don't we go on to the last talk? Yes, please. Thank you very much. Yeah. Let's get to the last talk.
Thank you, Valerio.
Yeah.
So is this Alëna's talk? Alëna?
Yes, please.
Hi. So we are actually booked for 2 sessions, for session 1 and session 4. So if you would like to stick to the original.
Well, I think Mark will be generous. We can go a little bit into his. We have a lot of people in this one.
Yeah. Okay.
All right.
So let me share the screen. And can you see it?
It's great. Thank you.
Yes, great.
So yeah, in this case, let me just give like a quick elevator in a tall building pitch talk about our presentation. So we are a team of Google Speech, and we wanted to share with you our thoughts about how to make benchmarking for speech recognition systems better. So the usual metric that you might be familiar with is word error rate. So it's approximately a percentage of the mistranscribed words. And in general, if we look at the recent publications, the word error rate is pretty impressive. So like data sets, the word error rate on some data sets achieves like as low as 1.4%. So numbers are actually looking very good, but it not always reflects real life ASR performance, right? Like due to many different reasons. So it might be quality differences for different language varieties. It might be different performance for different domains, or just the processing speed of the system is really, really slow. So we wanted to give you some ideas on how to improve the evaluation of ASR systems and not to stick to just a single metric, because Goodhart's law is applying here as well. When measure becomes a target, it stops being a good measure. So our main objective is imagine like what exactly can we do so that we're doing better evaluation of ASR systems, and we're proposing 3 main areas. So the first one is improving the types of data that we're using for ASR evaluations. So we need to include various domains as well as various factors, domains being dictation, conversation, different types of views, scenarios, and so on, and factors speaking rate of speech, so speaking rate, it might be different acoustic environments, loud or noisy, presence of specific terminology like medical and so on. Then the second big improvement that we want to highlight is metrics. So of course, word error rate is extremely important, but then how exactly can we get more insights from word error rate? And then also some metrics beyond word error rate, like latency, how fast the system is, how to understand the trade-off of latency, word error rate, usefulness of only partial results of the system output, and so on. And then, so those were the two areas. And then the third area is how do we actually ensure that it works for everybody? So here we're touching on the topic of language variety and how speech recognition systems work for different population groups, like be it gender, be it dialect, be it accent, and so on. So let me just quickly go through the talk. I will not focus on the details. I just wanted to give a couple of examples of bringing more diversity into data sets. So what we want to see there is, for example, dictation, so dictated speech. It's a bit different than spontaneous conversation because it's a bit slower, it's better enunciated, and there are some subtypes of dictations that are very important because those are the widespread ASR use case scenarios that are medical dictation that already brings in the complexity of the terminology that's constantly changing in the medical field, and also dictation practice and giving feedback to the learners. Then there are also voice control systems, like for example, when you're calling support and you're talking to a robot for some time. So this is also a widespread use scenario. So we need to have this domain represented as well. Then more spontaneous human speech, such as meetings, podcasts, movies, and beyond. But also we need to pay attention to some technical challenges that we might have represented in the data set. It might be terminology and phrases, it might be like medical terminology, some historical phrases and neologisms. So some people speak faster, some people speak slower, and we need to have both speeds, all types of speech represented as well. Then it would be also ideal to cover different types of the acoustic scenarios. Because, right, like we want to have ideally represented different types of the background noises and also encoding formats. Those are challenging, they produce some technical difficulties. So all of these ideally should be represented in a good data set. So that's the first part. Then just looking a little bit into the metrics. Again, word error rate, just like approximately means the percentage of words that were mistranscribed. And in general, we might assume that a system with a lower word error rate is better than the system with a higher word error rate. But then we can also imagine scenarios where our word error rate is lower in one case, but our latency is higher, meaning that the system is slower versus like the word error rate that's slightly higher and latency is much lower. And of course, if we are concerned with better system for like in the real world setting, we would prefer probably the system with tiny bit higher word error rate, but that works faster. So we would also like to highlight that we can look into word error rates under different perspectives. So first of all, word error rate treat every word equally, and it's not exactly always the fair scenario because, right, like some words might be more important to catch than others, like the word hurricane. Catching the word hurricane might have higher, more important consequences than recognizing a word like there, for example. Plus, it's just important to highlight that word error rate is not, so it's not comparable across languages, right? Because the word is a language dependent definition. And we can't say that like word error rate for, like word error rate of 5% for English is the same as word error rate of 5% for Cantonese, for example. Then we also need to pay attention to different written domain conventions. So the way we spell the words, like if we have some, if it's actually the same word, like 730, but in our machine generated transcript, we have like digits, and then in our human transcript, we have words, we will calculate order rates as well. So just something to be wary of is the differences in the domain conventions. And finally, we also can calculate order rates for different semiotic classes, be it numbers, addresses, names, words of a certain kind, or like domain terminology, frequent words, and so on. And it's important to know that the average order rate doesn't show the distribution of misrecognitions. So that's also something that we want to pay attention to. Then it's also, I will not go deep into this, but it's also useful to look into metadata about words. So like how sure we were about transcribing like a certain word. And also it's interesting to get not only orthographical transcription of the words, but also phonemic transcription, right? Because like there are words that are written in exactly the same way, but depending on the pronunciation, they mean different things, like live or live, or Houston, that's in Texas, or Houston Street, that's in New York City. So this is important as well. And then there are timing related factors like latency. So latency is an average delay between like when the word was spoken and when the system was able to transcribe it. So of course, we want the systems to output good guesses as early as possible. And yeah, also real-time factors. So how long did it take us to transcribe the audio in general? And then there are some special cases, like when the ASR system is streaming. So when we're recognizing on fly, of course, we also want to have good guesses initially. So ideally, we need to be measuring stability and quality of the intermediate guesses. There are also some other important dimensions, like how much data do we need to train, so contextual biasing, like the ability to, if we expect some particular type of the response to be given by the user, like yes or no, we can also bias towards that type of response. Hallucinations or recognitions of words when no speech was present, and how easy to debug the system. So those are just some other important dimensions that in the ideal scenario, we would be considering when evaluating a speech recognition system. And finally, how to actually make sure that the ASR systems work for everyone, right? Because there is linguistic variation and it can happen on very many different levels. And of course, it makes the task of the speech recognition harder. So, right, it might be phonetic differences, phonological differences, lexical differences, like maybe a speaker is using some word that's pretty rare, or like syntax difference, or even voice quality differences, right? Like that correlate with speech, so like different ages, genders, and so on. So all these factors are, of course, challenging factors for speech recognition systems. And it's important to count in all those factors when we're evaluating the system. So what we're proposing to do in the ideal scenario is to slice ASR quality metrics for various categories of speakers. So we need to know every metric, ideally for every category of speakers. And then we want to interpret the results per population group. So of course, the ideal test set should be representative of the target user base. And that's why it's important to have test sets that have very rich metadata. So like from where the speaker is coming, what's the dialect, what's the accent, what's the gender, and all those factors. And of course, it would be hard to expect the proportions of utterances to be the same as the proportions of people in the world, or proportions of types of speakers in the target user base. So we are proposing to reweigh the metrics by the sizes of the population groups. So take a look at the bottom of the slide. Let's say that we have a data set where 85% are featuring utterances of the type A and 15% featuring utterances of the type B. So, and if the population of the type A is just 60%, what we're proposing is to scale and actually consider the weight of the utterances featuring A as 0.6 and the weight of utterances featuring feature B as 0.4. So reweighing the metrics with respect to the size of the population group. And then, so let me continue into this framework, and let's imagine the following scenario. There are three groups in the population. one group is 60%, another group is 30%, and another group is 10%, and let's assume that they're mutually exclusive. So if we take a look at the plots on the right side, the width of the bars actually represents the sizes of the groups under this perspective. And why is it so important to actually look independently into quality of recognition for every group individually? So in this scenario, these two plots that we have on the right side of the slide, the word error rate overall is exactly the same. It's 10, right? Because like if we multiply the word error rate for a particular group, like 6.5, for example, by the size of the group A and so on, we will get the same word error rate in both cases. But if we look actually at the gap of the quality between the best performing and the worst performing group, we will notice a significant difference. So if we want to allow as many people as possible to experience like comparable rates of the recognition, of course, it's better to go for a model that's more consistent. So yeah, in the ideal scenario, the models will be more consistent for different speakers. Of course, speakers usually fall into different categories at the same time, but it will be very difficult to get sets where we have, like, let's say, yeah, we have 20-30-year-old female speaker of Chicano English from Miami, but it's hard to create a test set where we'll have that exact combination of features represented. That's why we're proposing to use mutually exclusive groups and calculating independently speech quality metrics for every parameter of every mutually exclusive group. So some of the important slices that we need to be considering include regional language variation, sociolects such as Chicano English or African American Vernacular English, for example, non-native language background, like be it a speaker of English with Russian accent or like be it speaker of German with Japanese accent and so on. We need to know how, depending on the accent, the quality of the speech recognition differs. Gender, age, pitch, and also speech impairment. So just to conclude, that we highlighted those three areas, and we feel that paying attention to those three areas will, of course, help us to evaluate speech recognition systems better. And even adding just some of those proposed perspectives will already be helpful, but by no means this list is exclusive. So we would like to invite more work into this. Thank you so much.
Well, that's great. Do we have any questions?
Thank you very much, Alëna.
Thank you.
I have a question, quick, if Mark allows this.
Go ahead.
Thank you. I would like to ask how much of this is, goes through all the systems that you're using.
I'm sorry, can you repeat the question?
Yeah, so I was asking, I'm sorry, I don't have a good internet connection. So I was asking, so the presentation was very clear. So they are used on all ASR that you're doing in the company, yeah?
This is the ideal scenario. This is something that would be ideal, that if we're in general evaluating the quality of the speech recognition, these are the steps how we can make it better. It's very hard right now, like make sure that like we can satisfy all of it and maybe even go beyond that. So this is more like an ideal scenario that we're proposing, that we would like to be working towards and inspiring other people that are working with ASR to do as well.
And you would like to go multilingual also?
Sorry.
You would like to go multilingual also, I suppose.
What exactly do you mean here? Do you mean that we would need to have a special types of evaluations when we want to like allow for code switching in the data, for multilingual groups and so on? Yeah, of course, multilinguality will be another dimension, and thanks so much for bringing up this point. Yeah. multilinguality of the speech recognition, of course, is also a big challenge. And see, we're already expanding the set of proposed metrics that we just discussed.
Thank you, Alëna. Thank you.
Thank you.
Sorry for the sound.
So I just shared in the chat some data that I get to see that you guys don't get to see, which is all the views on YouTube of all the videos that I shared. And this talk is in second place, ahead of Dave Ferrucci, who's the guy behind Jeopardy.
Oh, wow.
Yeah, right. Yeah, it's only behind John McCool. And John McCool's talk's been up for a lot longer. If you put your talk up well before deadline, you get more views. Anyway, yeah, this talk has a lot of really great data. I encourage you to go listen to the full talk and to read the paper. Yeah, it's really well done. And I also encourage everybody to go listen to all the videos, especially if you listen to the videos you like, then they go up the bill. You know, I vote early, vote often, and yeah. Anyway, just shameless plug for the workshop.
Oh, Yana had raised the hand. I just saw on my
please
on my cranky mobile. I'm sorry.
No, thanks for the talk, Alëna. So I have a question, maybe a bit more high level. So Esch has been like existing for a while, and there's been a lot of work on that. And I guess like in recent years, the performance starting to reach some saturation, and it seems like based on the original evaluation metrics, it seems like we're getting close to like really good performances. And now that we're getting there and we see that in practice it doesn't work maybe as well as we'd expected to, like your research, you show that other alternatives of other evaluation metrics and so on to get a better sense on how good we are at this task. So a question about like other kind of tasks, so maybe newer tasks that people suggest new tasks and new data sets to test on. Do you have any thoughts about should we go look at the more complicated evaluations from the beginning, or should we just like suggest new like simple metrics and or metrics for each task, go for that for a while, try to get to good performances, and then only then start to look in more details and depth if we can do better?
This is definitely a very interesting question. I don't think that I have an answer that will be like one or another. So I think in general, it will be useful to go both ways because both of them will be pushing towards the better ASR benchmarking, more inclusive speech recognition systems, and so on. There might be some arguments towards introducing the complexity right away so that we don't get a system that's like works better for one category than another. So that, but we will figure it out only later on. There might be some also arguments towards just first keeping it simple, just to start this idea and then making the evaluations more and more complicated. But it definitely would be great to have more benchmarking sets, and it would be super important to have better and more representative benchmarking sets. And of course, like having competitions would probably increase the participation in this type of work. So yeah, that would be really helpful. Thank you.
Okay, thank you very much. I don't see any other question, but perhaps somebody may help who has a better global view.
No, I don't see anybody's hand up. If it is, please speak up.
I had mine up for just two questions if there's time.
Please.
So as far as I understand, the sort of population-weighted evaluation is very similar to sort of importance weighting in domain adaptation. So the idea of sort of resampling your data so that you simulate the target distribution. Now, a sort of by the way, thanks for a great talk. That was super interesting. Now, in domain adaptation, one problem, of course, is sort of predicting what the target distribution will be in the future. And you sort of refer to the notion of the population of end users, but that is also drifting, I assume, over time. So this is one question, sort of how to adapt more dynamically to that. And then the second question is whether, I mean, if you're a minority, trained, so I understand your approach is sort of meant to address biases in the training distribution, but if you're a minority of train time and test time, you're still going to be, your concerns are still going to be less important to the overall average. So from a fairness perspective, is there sort of an argument for worrying about worst case performance across the groups that you define rather than this reweighted distribution, or are you considering sort of alternatives in between the two to account for the fact that the errors you see with minorities may be catastrophic for them, and that should sort of, you want to penalize that more perhaps?
Yeah, so I feel that I don't have a ready answer for this because, right, it's all like brainstorming what would be the ideal scenario of things. So as of the target user groups, so since we can try to understand what groups of users are adopting the technologies with a higher speed and which groups need the technology the most. For example, the populations with the lower literacy rates will benefit so much from these technologies. It's literally like giving them access to some things that they never had before. So it really needs, we really need to pay attention to like all groups like this. What exactly scenario to adopt? This is an open debate right now. So I think there is a paper by Meg Mitchell and team comparing like, so what exactly do we need to be doing? Do we need to be looking into the decreasing the gap, or do we need to be focusing more on the worst case performance groups? So yeah, no ready answer for this. This is definitely an open topic. And as of the different, as of the domain adaptation and how to predict this, actually, if Daan is still here, maybe you have some thoughts to share about this.
Yeah, I don't immediately like have an answer. I think like Alëna is saying, it seems like a sort of open problem, right? One thing that does also seem like an interesting indicator is the gap between the worst group and the best group, right? That could be something where you might want to factor that in as well. But we have a lot of, like within Google, we have a whole bunch of people sort of, I guess, like looking at both angles of your question, right? So there's a whole bunch of user experience researchers, for example, who are looking at who is using the technology, who wants to use it, but is not able to use it, right? Because it's not working well enough for them. That's another sort of important consideration. So that's actually, like, I think they have a separate paper coming out on some of their research there sometime soon. And then we have a whole bunch of folks actually looking at, okay, well, how do we actually, you know, adjust these algorithms at training time, right? Maybe we can, you know, make sure to balance the training data in a different way than these benchmarks. You know, obviously you can report on these different like slices as well. It's a very hard problem, right? And somebody was asking earlier, are we thinking about other languages? You know, we support, I think, about 120 language varieties these days. So obviously not straightforward to collect this data even for English, but then think about doing it for Kazakh, you know, and that's sort of a different problem again. So yeah, definitely a lot of interesting problems here to go through. And we have some other benchmark data sets hopefully coming up later this year as well. Not that we can do all of this here, but, you know, hoping to sort of go in the right direction at least.
All right. Well, I'm embarrassed at how much we've gone over time. But anyway, this is a really great talk. Let's thank the speaker. Yeah.